right, I guess we're ready. Good morning. The Subcommittee on Space and Aeronautics will come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled The Federal Aviation Administration's Flight Plan, examining the agency's research and development programs and future plans. I'll recognize myself for 5 minutes for an opening statement. Good morning and welcome to the Space and Aeronautics Subcommittee hearing to review the Federal Aviation Administration's FAA portfolio of research and development programs to examine priorities and challenges. I want to welcome the new members of our committee, this subcommittee this Congress, and I'd like to extend a special welcome to our new ranking member, Congressman Sorensen. Good to see you this morning. I look forward to working with you this Congress. I want to thank you and thank our panel of witnesses for taking the time to share their expertise with us this morning. I'm very eager to hear your testimony, which will inform the committee as we draft legislation authorizing the FAA's research and development activities, examine research priorities, and support investments that are balanced between strategic and mission-oriented projects. The Science Committee has a long history of work on FAA's research and development activities. The most recent FAA authorization signed into law in 2018 included the Flight R&D Act, authored by this committee. Among the notable provisions included was the creation of a new position within FAA to oversee the agency's research and development activities, as well as language directing that an increased share of funding must go towards safety research. Today's hearing is an opportunity for members to learn about the implementation of these provisions, as well as policy considerations that we should consider as the current FAA authorization expires this September. The aviation industry is a crucial component of our economy and our national security. It is the backbone of global trade, connecting people, goods, and ideas across borders. The FAA supports this industry by setting aviation standards, improving safety, increasing efficiency, and developing new technologies. In short, the FAA's research and development work drives progress in the aviation industry, which in turn makes America more globally competitive. America has long been the global leader in aviation standards and technology. That leadership is being challenged, however. The largest growth sector in this industry is not here in the United States, but unfortunately in Asia. If we are going to maintain our competitive advantage, we need to invest in the growth of new technologies, strategically prioritize our funding to ensure safety, and to provide a competitive environment for industry. We must also stay at the cutting edge of technological development. One area where R&D support is especially important is advanced air mobility and unmanned aircraft systems. The rise of UAS, commonly known as drones, can be transformative in how we approach public safety, emergency response, and even rural infrastructure. But the development and integration of AAM into the national airspace system poses significant technical, operational, and regulatory challenges. We must address these if we're going to stay competitive in the growing drone industry. Unfortunately, we don't have endless resources to support the FAA. As lawmakers, we need to make strategic decisions about our research and development priorities. We also need to provide oversight to hold the agency accountable for its performance and ensure that its programs are aligned with the needs of the aviation industry and the American people. Finally, we need to ensure that there is coordination between public and private sector efforts so that we can minimize duplication that may crowd out private sector investment, which has historically been critical to the U.S. aviation sector's success. I look forward to hearing from our witnesses today about how we can strategically address these challenges, and I hope to learn more about the status of FAA's research and development programs, how FAA is identifying research priorities, and how we in Congress should proceed as we consider the next FAA reauthorization bill. So I now recognize the Ranking Member Sorensen for his opening statement.
Thank you very much, Chairman. Before I start, I'd like to share how excited I am to be a ranking member on the Subcommittee on Space and Aeronautics. I'm pleased to be working with Chairman Babin, the full committee Chairman Lucas, and Ranking Member Lofgren. I'm proud to be the son of an aerospace engineer who worked in aviation and the space shuttle program. So this is in my blood. I grew up in Rockford, Illinois, and took my dream job as a meteorologist. And of course, we all know that weather impacts everything. It's an understatement to say that I am absolutely excited to be here. I want to welcome our new and returning Democratic members of the subcommittee. I look forward to working with everyone and our majority colleagues on what promises to be a busy and important year for space and aeronautics policy. Returning to our meeting, thank you to Chairman Babin for holding today's hearing to examine the FAA's research and development programs. I want to welcome our distinguished panel of witnesses here today, so thank you all for being here. As members of Congress who commute back and forth between our districts in Washington, D.C., often weekly, we depend on the safety and the reliability of our nation's air transportation systems. So thanks to the thousands of men and women at the FAA and its industry partners, the United States has maintained a strong safety record in commercial air travel across many decades and generations. FAA's research and development activities are central to ensuring our safety. Fire safety, aircraft de-icing, flight traffic management, and airport pavement. I mean, these are just a couple of the examples of research that continues to drive safety at the forefront, and it means that our U.S. commercial aviation industry is successful. It's important to recognize, however, that the COVID-19 pandemic had devastating impacts on commercial air travel and our supply chain. While recovery is still underway, the number of world total passengers in 2022 was still down by 29% as compared to 2019 before the pandemic, according to the International Civil Aviation Organization. Today's hearing provides an opportunity to explore how research and development can help build resiliency into our national air transportation system. Commercial aviation is on the cusp of transformational changes to bringing with it the potential for economic growth, jobs, innovation, and environmental stability. Fully benefiting from these opportunities and ensuring the United States leadership will continue and will require managing significant changes to the already complex National Airspace System, the NAS. Emerging technology like drones will be joining the skies along with piloted commercial passenger airplanes, and we need to make sure that safety matches the technological innovations. In addition, the demand for lighter, quieter, more fuel-efficient and climate-friendly aircraft are leading to new aviation technologies, including biofuels and electrification. So I have confidence that the FAA, the United States aviation industry, and the nation's universities can successfully work together to navigate all of the changes. And if we give them the appropriate policy direction and resources, we can do it. That's why today's hearing is so important. The subcommittee will prepare R&D title for this year's FAA reauthorization, and our discussion this morning will inform that work. To that end, I look forward to hearing from our witnesses to the following questions. Is FAA's R&D effectively addressing the challenges of integrating new and evolving technologies and systems into the NAS? To what extent is FAA's R&D advancing U.S. leadership in sustainable aviation, reducing our environmental impacts, and meeting the Biden administration's target goals for achieving net zero emissions by 2050? Do the FAA and the industry partners have the workforce that's needed to meet the challenges? How can we build resiliency into our commercial air transportation system to mitigate the effects of unplanned stresses on the system? And so I do, again, want to thank our witnesses today for being with us. I look forward to your testimony. Thank you, Mr. Chairman. I yield back the balance of my time.
Thank you, Mr. Sorensen. Appreciate that. I'd also like to welcome our full committee chairman, Mr. Lucas, who is here, and also the ranking member, Ms. Lofgren. Thank you for you all for being here. And I would now like to recognize Mr. Lucas, our full chairman, for his statement.
Good morning, and thank you for holding this hearing, Chairman Babin. It's no accident that today's hearing is the first subcommittee hearing held by the Science Committee this Congress. Some of our colleagues might not be aware of this fact, but the Science Committee has jurisdiction over a wide range of FAA's research and development activities. Though not as high profile as FAA's other activities, this research and development is vital to improving American aviation. FAA's R&D is geared towards activities such as reducing fuel consumption, flight times for airlines, utilizing better structural materials on aircraft and at airports, and researching the effects of flight on human health. This committee typically drafts legislation that authorizes FAA's research and development activities, which is then incorporated into the larger FAA reauthorization bill, or authorization bill. The current FAA authorization expires at the end of September, and I look forward to working with members of this committee and my colleagues on both houses of Congress to enact a new bill. Aviation R&D is not only a matter of national interest, it's also an issue that's particularly important to my constituents back home. Oklahoma is home to cutting-edge aeronautical research. The Civil Aerospace Medical Institute, often referred to as CAMI, is located at the Mike Monroney Aeronautical Center in Oklahoma City. For more than 60 years, CAMI's focus has been on human factors of flight and how conditions like fatigue or illness can impact pilots' performance during air flight. CAMI's research has contributed to important features which make flight safer, such as drop-down oxygen mask and illustrated floor lighting. The FAA R&D that should be authorized this year will continue to build on successes like these, making aviation safer, more efficient, and more reliable. I want to thank our witnesses for appearing before the subcommittee today, and I look forward to your testimony. And again, thank you, Mr. Chairman, and I yield back.
Yes, sir. Thank you, Mr. Chairman. Now recognize the ranking member of the full committee for a statement as well.
Well, thank you, Mr. Babin. Thanks for this hearing, and welcome to Mr. Sorensen, your first hearing as ranking member. It's great to have you on board with your history and expertise, and Mr. Chairman, you as well. Aviation needs to be safe for all stakeholders. We've talked about the crew and the passengers, but it also needs to be safe for the communities that surround airports. And I think the FAA has to have a clear, coherent strategy to ensure that R&D is focused on solving some problems about that. Now, I want to just focus in on one thing because it has emerged as an important issue for me, and it has to do with leaded gasoline in general aviation airplanes. You know, general aviation is the last place where leaded fuel is used. And there's a small general aviation airport in San Jose, Reed Hillview Airport, and the county of Santa Clara commissioned a study of the children surrounding that airport. And what they found was a lead in the blood of those children that exceeded that of lead around Flint, Michigan, the children who were exposed to that toxicity. In response, the county stopped selling leaded fuel at that airport, and the FAA actually threatened to sue them to force them to poison the children. Since that time, the president intervened and the secretary intervened, and an agreement has just been reached with the county as a pilot project that they can dispense only unleaded fuel at that airport and a small airport south of Reed Hillview Airport. That's important for those children, but the children of the rest of the country continue to be exposed if they're near a general aviation airport to leaded fuel. Now, I know that we are looking at this. We had, last year, the FAA announced a government industry partnership called the Eliminate Aviation Gasoline Lead Emissions EAGLE initiative. And I think that's fine, but the goal is to have a solution by 2030, and I really think that is not an ambitious enough goal. Meanwhile, between now and 2030, children all over the country will be exposed to lead, and what we learned in San Jose is it's the mist in the air, and the children inhale it, and it's very toxic to them. There is no safe level of lead. So I'm interested in what concrete solutions we can devise in the R&D section to accelerate this, and any comments you may have either at this hearing or subsequent to the hearing, because I think this is an emergency, really, for the children of America. With that, I fully support the comments made by the chairman in terms of the broader initiative, very important work that you do, and I yield back the balance of my time, Mr. Babin.
All right, thank you very much. Now I'd like to introduce our witnesses. Our very first witness today is Ms. Shelley Yak, who is the director of the William J. Hughes Technical Center. Prior to becoming the center's director, she served as the deputy director of the Technical Center and as the division manager of the center operations team. Mrs. Yak has served the FAA for over 20 years and brings extensive experience to the agency's R&D efforts. Should we recognize her to speak right now? Okay. Our next witness is Dr. John Hansman, who is the T. Wilson Professor of Aeronautics and Astronautics, as well as the director of the International Center for Air Transportation at MIT. He also chairs the FAA Research and Development Advisory Committee. And Dr. Hansman also serves as the co-director of FAA Center of Excellence for Alternative Jet Fuels and Environment, known as ASCENT. He is a fellow of the AIAA and a member of the National Academy of Engineering. I will now recognize Mr. Sorensen for introduction of our final guest. Let's see, I think we just left off one, did we not? Sorry. You're going to introduce the next one. I apologize.
Thank you,
Okay.
Chairman Babbitt, for granting me the honor of introducing one of our esteemed witnesses today. I'm so proud every day to serve the people of Central and Northwestern Illinois. Today I'm especially proud because we'll receive testimony from an expert based in my district, Illinois 17. Mr. Eric Cunningham is the Vice President of Electric Power Systems at Collins Aerospace, based in the great city of Rockford, Illinois. During his career with the company, Mr. Cunningham has held roles in engineering, engine control systems, and electric power systems, program management for military and commercial programs, quality and operations. Mr. Cunningham has spent the past several years in customer-facing roles leading the Electric Power Systems International, Business and Regional Jet Value System, and most recently, the Electric Power Systems Military Value Stream. Mr. Cunningham earned his bachelor's degree in electrical and computer engineering from the University of Illinois, specializing in power and energy systems. He's also a master's of business administration from Rockford College. Mr. Cunningham grew up in Winnebago County, Illinois, just as I did, and he is an example of the innovation and the leadership of our home community. Rockford has a rich history in aerospace, and I'm excited for our hometown that we continue exploration and innovation. Thank you, Mr. Cunningham, for being here today and sharing your insights on these important subjects. And thank you, Mr. Chairman. I yield back.
Yes, sir. Thank you. I now recognize Mrs. Jack for 5 minutes to present her testimony.
Thank you, Chairman Lucas, Ranking Member Lofgren, Chairman Babin, Ranking Member Sorensen, and the members of the subcommittee. Thank you for the opportunity to appear before you today to discuss FAA's research and development portfolio. My name is Shelley Yak, and I am the director of the William J. Hughes Technical Center and represent the FAA as the research director. From 1958 to present day, many of the concepts, technologies, and systems in the national airspace was researched, developed, tested, and began their nationwide deployment at the Technical Center and its sister center, the Mike Mulroney Aeronautical Center in Oklahoma City, where the Civil Aerospace Medical Institute is located. Through our federal laboratories, our workforce, and our partnerships with industry, academia, and government agencies, the two centers are able to turn ideas into value and problems into solutions. The work we do ensures that the United States continues to lead the world in embracing, implementing, and integrating new technologies. Entrepreneurs around the world are exploring innovative ways to use aviation in their commercial activities, and the need for us to integrate these new technologies into the national airspace system continues to be a national priority. The research, development, test, and evaluation work of the FAA is best summarized through 6 domain areas, which I wish to briefly share with you today. To do so, let us go on an imaginary flight together. We start our trip, of course, at the airport technologies and infrastructure domain, today's airport, where we do research and development on various pavement materials and assessing soil types to determine their impact on the longevity of our runways, the largest capital expense of an airport. We then board the aircraft. This is the aircraft safety assurance domain. Our work here has everything to do with the aircraft, from the skin, which is made up of composites and other new materials, to propulsion and fuel systems, and aircraft fire protection and detection. Still on the aircraft, we begin settling in, and that means interacting with the entertainment system in front of us, while our cockpit staff are interacting with their digital systems and technologies, our 3rd domain. This includes everything electronic on the plane and across the national airspace system: aircraft systems, introduction of electronic flight bags into the cockpit, and cybersecurity across the national airspace system. Well, it looks like we're waiting to take off. The number 1 cause of delays is weather, and weather mitigation is part of the environment and weather mitigation domain. In this domain, we perform research on everything that affects aviation or is affected by aviation, such as improving weather forecasts, mitigating ice, the effect of noise and emissions on our environment and communities, and the viability of new replacement fuels that will lower emission levels. As we're waiting for takeoff, let us not forget the people we depend upon during our flight. Our human and aeromedical factors domain supports our pilots, technicians, and air traffic controllers, and is where we look to ways to improve human performance. The research conducted here on how people best interface with systems they use and developing training requirements. The Civil Aerospace Medical Institute is the location for all of FAA's aeromedical research. We finally take off, and you know your pilot and air traffic controllers are well trained and checked out. The last domain to the passenger is behind the scenes. However, it is the most important domain for getting us to our destination, the aerospace performance and planning domain. This domain includes the air traffic management of our flight and the tools and the systems we use to ensure we safely arrive. It includes the safety management systems we have in place and the integration work we are doing for emerging operations, such as commercial space transportation, UAS, and advanced air mobility. Our flight proceeds, and we even make up the time we lost waiting on bad weather due to the tools and forecasting systems we talked about in 2 of our domains. We land safely at our destination airport, a smart airport, the one we are envisioning and researching for our future. Throughout our history, the FAA has adapted to changes in technology and has successfully integrated new operators and equipment into the NAS, and we are well positioned to maintain our global leadership status. We are committed to working with you and finding solutions that balance safety and security with innovation. This concludes my statement, and I'll be happy to answer your questions at this time.
Thank you, Ms. Jack. Appreciate that. And now I recognize Dr. Hansman for 5 minutes to present his testimony.
Chairman Lucas, Ranking Member Lofgren, Chairman Bevan, Ranking Member Sorensen, and members of the committee, thanks for the opportunity to talk about the FAA research and development needs moving into the future. As noted, I chair the FAA R&D Advisory Committee. However, due to the lack of time, I haven't been able to fully coordinate my comments, so I'm actually speaking as an individual today. The FAA has a unique research requirement because of its role in overseeing the system in the U.S., the airports, the pilots, the airplane certification and operations. In addition, it operates the system, it operates the air traffic control system and many parts of the NAS. So it has unique research requirements. let me just talk about some of the needs and things that we've discussed and think are important. First is, how do we move forward to increase safety in a system that's incredibly safe? The U.S. air transportation system is one of the safest but most complex in the world. We haven't had a fatal commercial transport accident in the U.S. in almost 10 years. So the way we have improved the system and made it so safe historically has been to look at incidents and accidents that have occurred and then make improvements to the system to mitigate risks that we found. We need approaches now to identify risks before they emerge as accidents. So there's needs for advancement in looking at data, monitoring data, operational data, et cetera. There's another subtle but important factor of the incredible safe level of the system, which is it's actually hard to modernize the system because people present the FAA with new technologies and things that they want to do. But how do you know that when you introduce that new technology or change the system or try to make it more efficient, you're not introducing risk? So there's actually research required to think about different ways to monitor, improve, and introduce new technologies and operations into the system. Another area that's emerging, and it's actually an area of success for the FAA, is the importance of sustainability and mitigating the environmental impact of aviation. The FAA has actually done a pretty good job on it, and it has a leadership position worldwide based on the research that's been conducted at the FAA, particularly through the Office of Aviation and Environment. So the REAC has noted that that's an action area of success. Getting back to the safety issue, there are real challenges in the future on how we actually approve, certify, and allow operations of the new technologies that people would like to introduce in the system. The FAA appropriately is conservative because of its mission of maintaining safety, but some of the new technologies, electrification, use of artificial intelligence, automation in the aircraft, how do you certify non-deterministic software, are real hard technical challenges. And this relates to something else that the chairman had mentioned, which is how do we have the workforce, both in the U.S. and particularly within the FAA, in order to be in a leadership position, or at least a knowledgeable position, to know what's okay to approve and what's not okay to approve. So it's important for the research not only to do the underlying research to understand the technical risks and performance of the system, not the development of the new technology, but you need to understand it well enough so that you know what's good to approve. And so research is required there both to find answers to key questions, but also to develop the competency within the agency so that they're in a knowledgeable position to move forward. The final comment I'd like to make is the challenge, and this is based on my observation of the FAA research over the years. The FAA is challenged to respond to emerging issues. Because of the way the budget process works, they need to lay out their research requirements 3 years in advance. And then it takes you a couple of years to do the research. So when something new shows up, COVID, spectrum issues, UAV issues, someone presenting the FAA with a requirement to certify an airplane that nobody's ever thought about, a lot of the challenges of the AM aircraft and electrification that as they move forward, it can be challenging when something unexpected shows up. So I think there's value in thinking about ways to add some flexibility or some contingency options, because the way it works now, it's actually hard for the FAA to be able to pivot to address a new and emerging issue. So I'll stop there. Thank you.
Thank you, Dr. Hansman. Appreciate that. And I now recognize Mr. Cunningham for 5 minutes.
Chairman Lucas, Ranking Member Lofgren, Chairman Babin, Ranking Member Sorensen, members of the committee, on behalf of Raytheon Technologies and its Collins Aerospace business, I want to thank you for the opportunity to share some thoughts today on an issue at the forefront of our company and the entire U.S. aerospace industry. The research and development programs that will define our next generation aircraft to make flight more sustainable, efficient, affordable, and while improving safety and reducing noise and emissions. As I look across the roster of the subcommittee, I'm pleased to note that Collins has major facilities either in or near the districts of every single member. It's a particular privilege to represent a company with major facilities in both the chairman and ranking members' districts, with the Collins Houston Spaceport site in Chairman Babin's district. Also in the Rockford, Illinois region, which happens to be the 6th largest aerospace employment hub in the United States, Collins has a facility represented by Ranking Member Sorensen, where I have the honor of serving as a site leader on behalf of our more than 2,000 employees, working in power and controls, mission systems, and advanced structures businesses. For over a century, the U.S. industry has played a leading role in developing the technologies that led us from first flight to supersonic flight and everything in between. For the past several decades, there were a great deal of new commercial and military platforms developed and certified. That generated extensive domestic expertise and capability. However, since the certification of these aircraft, there's been a sharp decline in commercial development, as well as a refocusing of military investment into recapitalization of existing platforms, creating a unique point in the aerospace industry. So based on this context provided and other global factors, there's 5 discrete unique challenges facing the aerospace industry I want to mention today. The first is technology maturation. The next round of aircraft are going to demand a step change in technology, incorporate into their designs to support improved efficiency, reduce carbon footprint, and lower operating costs. Airframers are now expecting full demonstration of these new technologies in advance of the launch of that aircraft, which is a change from a past when much of the technology was matured during the aircraft development. The second is U.S. competitiveness. As we look at the global competitive landscape, we see several major trends and challenges to longstanding U.S. leadership in aviation, such as orders of magnitude higher levels of R&D spending globally, expiration of the R&D tax credit, and increasing global pressure around sustainability goals. Continued leadership in aviation requires both industry and the government to focus their policies, investments, and R&D programs to mature those new technologies. The third is an increased focus on safety. Over the last 2 decades, digital design tools and simulation have facilitated design specifications based on formalized modeling languages, allowing multiple organizations involved in delivering complex systems to work with consistent representations of the overall system. As a result, digital systems can be used to link functional safety hazards that emerge during design, testing, and in service to improve product safety and potentially streamline certification. The fourth is sustainability. The aerospace industry is focused on all aspects of sustainability, from the environmental footprint of manufacturing to the operation of the aircraft itself. There's a great deal of technology maturation required to support sustainability in areas such as sustainable aviation fuel, hydrogen, or even hybrid electric propulsed aircraft. And the last is workforce development. The U.S. aerospace workforce and its relative level of expertise and capability has been negatively impacted by the current lack of new aircraft development and certification programs, reduced manufacturing demand, and an aging workforce with high levels of retirement, as well as a challenging financial situation that's resulted in workforce reductions, some temporary, some permanent. So as I mentioned in my written testimony, there's 4 key recommendations for R&D programs in the FAA Reauthorization Act of 2023. The first is increased authorized funding for FAA R&D to ensure continued U.S. competitiveness. The second is to align FAA R&D and other federal research programs around the key technology areas necessary to demonstrate efficiency, sustainability, and competitiveness goals. The third is expand on the Fueling Aviation Sustainable Transition Program. And the last is to improve coordination with NASA on technology roadmaps, funding, and flight testing. In conclusion, I want to thank Chairman Babin, Ranking Member Sorensen, and all the members of this committee for the opportunity to appear before you today and share these industry perspectives on R&D opportunities in your upcoming authorization bill. The oversight and authorization work you do is critical to ensuring continued competitiveness in global aviation and for the decades to become. Policies and programs that support continued R&D investments at the federal and industry level and encourage successful public-private partnerships will be key. Thank you.
Thank you very much. Appreciate you, Mr. Cunningham. And now I recognize myself for 5 minutes for questions. The FAA's Notice to Air Missions, or NOTAMs, system recently experienced a system outage causing the first nationwide grounding since September the 11th of 2001. The FAA indicated that the outage was caused when contract personnel unintentionally deleted files while working to correct synchronization between the live primary database and a backup database. The agency has so far found no evidence of cyber attack or malicious intent. This highlights the challenges facing FAA's aging systems. The Next Gen program was intended to revolutionize the modernization of air transportation. But as various advisory groups have highlighted over the years, Next Gen became more of a program to implement incremental change and to maintain legacy systems. Mrs. Yak, can you speak for a moment on what FAA has done to upgrade and modernize the NOTAM system, particularly from a research and development perspective?
Thank you for that question. In regards to the NOTAM system outage itself, that is outside the realm of research and development. My understanding is that FAA is continuing to investigate the incident. It's more of an operational system.
Okay. Recent near misses and close calls, one in my own home state of Texas in Austin a few weeks ago, prompted the FAA to issue a call to action memo and establish a safety review team to examine the U.S. aerospace system's structure, culture, processes, systems, and integration of safety efforts. The FAA also indicated that it will hold a safety summit in March to examine what additional actions the aviation community needs to take to maintain our safety record. The 2018 FAA Reauthorization Act requires FAA to allocate 70% of its research and development appropriations for safety. So, Mrs. Yak, what has the FAA done and what is the FAA doing from a research perspective to better mitigate these near misses and these close calls? Or possibly hiring or training practices, have they changed or anything? Just want to hear what you have to say about that. Thank you.
Thank you for your question. There are a number of efforts we have underway that we're researching to better communicate information and data, so that would fall into our digital systems area that I talked about earlier. You've hit a passion point for me, and that is how are we preparing our workforce for the future? We have very active STEM programs, science, technology, engineering, mathematics programs in place, as well as a robust internship program to allow us to get that passion for aerospace out and K through 12, and then have them interested in working in the aviation industry, not just FAA.
Okay, thank you. And finally, the 2012 reauthorization directed FAA and NASA to conduct research to enable the development, certification, and adoption of alternatives to leaded fuel used in many piston engine aircraft. The goal was to approve an alternative fuel by 2018. So, Ms. Yak, can you give us an update on the Piston Aviation's Fuels Initiative, or PAFI, and eliminate aviation gasoline-lead emissions, EAGLE initiatives? And to what extent is this a research problem versus a logistic and infrastructure problem or a market adoption challenge?
Thank you for that question. We are very committed to safely reducing and ultimately eliminating leaded fuel. We have a very active program at the Technical Center where we have testing facilities established. So in coordination with the Piston Aviation Fuel Initiative, you mentioned PAFI, we are able to start testing alternative fuels. Today, we have one that's we've identified some discrepancies in, and we're working with that vendor. And we're right now working on a 150-hour engine durability test on the second fuel. So we're making progress.
Okay. Thank you very much. Now I would like to, actually got one more. I think I've got a little time. Mr. Cunningham, Collins also owns a Flight Aware, which was founded and headquartered in Houston. Your testimony mentioning the value of FAA R&D programs leveraging connected aviation systems and data science applications, which have dramatically advanced in technology and capabilities even since the last FAA reauthorization. How should the FAA be partnering with and leveraging innovations in the connected aviation systems sector to better integrate the streams of data that come in from ADS-B transponders, air traffic management systems, and the sensors that companies have now built into key parts and systems across the aircraft?
Thank you for the question. Collins Aerospace is actually one of our 6 business units is Connected Aviation Solutions. And so one of the suggestions that we would put forward is the more we can connect all the data that's now available into these systems with the right algorithms to create safe flight profiles and help guide us on how we need to manage our airspace, I think the better off we're going to be. So the more we can connect the data that's out there between all the different organizations, between industry and government, I think we can come up with better solutions.
Okay, thank you very much. I now recognize Mr. Sorensen for 5 minutes of questions.
I'll begin with you, Mr. Cunningham. In your prepared testimony notes that that other countries are investing heavily in aeronautics R&D and at levels that may surpass those of the United States. How concerned are you about the level of the United States investment to advance aviation technologies and innovation? And I think the follow-up would be, what would be your top priorities for increasing the investments in these R&D programs and why?
Okay, thank you for the question. You're absolutely right. If you look at Europe, for example, their investment into R&D is a little over an order of magnitude higher than what we have in the United States. Now, that can benefit companies in the United States, but oftentimes that's going to ultimately have a long-term benefit for Europe because they're the ones investing the money. When I look at what we can do with that, it's the technology itself around especially areas including sustainability and safety. But Dr. Hansman brought up an excellent point, which is the technology itself is very much the step in the right direction. But how we certify that technology and how we safely put it into practice is going to be key. So take, for example, hybrid electric propulsion. We've got a great amount of investment going into that, both from our own company as far as the government as well. But we don't yet know how to certify a hybrid electric propulsion system on an aircraft. That's going to be equally important as the technology itself to actually facilitate getting that out there, even into areas like general aviation, which we think is going to be one of the early adopters of technology like that to help sustainability.
As we all know, weather is one of the most dynamic factors that affects flight schedule. From small-scale thunderstorm complexes to, for instance, the big Arctic blast that nearly halted air travel before Christmas. Weather is a stress point that can lead to real economic and human impacts. In the near future, FAA is likely to be managing new types of systems in the airspace. Dr. Hansman, it's not just manned aircraft that are stressed. To what extent do new systems such as drones respond to weather differently than commercial aircraft, and how important is it that the FAA and drone operators understand how those operations respond to different parts of weather?
Sorry. So the small UAS and particularly small UAVs are subject to different types because they're small. Turbulence will impact them differently. Most UAS can't operate in icing conditions. If they ice up, they have problems, et cetera. For small UAS, it's not such a problem because if the airplane goes down, it's bad as long as it doesn't hit a person. It's going to be a real challenge as we move to more automated system. So ultimately, there are people who are proposing to fly large UAS autonomously and whatever. It's tricky for some of these systems to be able to know, for example, whether to go around or through a thunderstorm. Today, that's done as a subjective analysis by the pilot. So, again, how do you decide that an autonomous system is good enough to know whether to go through a thunderstorm, around it, or over it? The other thing I would say on the weather side is that we are in a much more connected world. So on the cockpit today, I have much more information than I had years ago. It used to be you would play 20 questions with the air traffic controller to try to figure out whether the thunderstorm was bad or not. Now you're getting data from many sources. So I do think we're in an area of improvement there.
How is, and forgive me for going into meteorology more as the meteorologist, but how is the FAA doing the research such that as the innovation of UAS continues, we're able to meet the demands?
Yeah, so there's a couple parts to this. First off, that the FAA is involved in distributing the information and setting up requirements. Much of the research associated with the meteorology is done by the National Weather Service, National Center for Atmospheric Research, et cetera. So there's efforts such as weather in the cockpit, efforts to try to figure out how to present the information to the crews better, et cetera. There's another thing, which is the airplanes themselves become probes in the system. So they're microsensors that propagate through the system. So how do you integrate that? One of the things in the plans that we've been trying to do is system-wide information management, figuring out how to send information to everybody. We haven't been as effective as we had, and the NOTAM is sort of an example of this, in part because if you make the system connected, you introduce new vulnerabilities. So now you're more subject to a cyber attack because someone can get into that. So this is the challenge of this incredibly complicated and safe system, trying to figure out what's okay to turn on to get the advantages that you'd like to get.
Thank you very much, Mr. Chairman. I yield back.
Yes, sir. Thank you. I would now like to recognize the gentleman from Oklahoma and chairman of the full committee, Mr. Lucas, for 5 minutes of questions.
Thank you, Mr. Chairman. I'd like to turn to Ms. Yak. The 2018 FAA reauthorization directed the FAA to appoint an assistant administrator for research in order to better coordinate research and development across the entire agency. Can you give us an update on how FAA has implemented this requirement?
Thank you for the question. The agency has considered a couple of different approaches to this directive and have not yet reached agreement with Congress on the approach. However, we are continuing to work this one.
But the agency's noted how important Congress felt this requirement to be to help facilitate. Good. Continuing, the Civil Aerospace Medical Institute, better known as CAMI, is located at the Mike Monroney Aeronautical Center in Oklahoma City and is a medical certification, research education, occupational health wing of the FAA's Office of Aerospace Medicine. Can you please discuss how CAMI is informing future decisions on issues such as pilot age limitations and health restrictions to alleviate pilot shortages in a safe manner? Could you expand on that?
Thank you for the question. We have a very close working relationship with CAMI, and I speak with the director, Melcher, on a monthly basis. So a lot of that's outside of my realm of expertise. Mm-hmm. So when Melcher talks, I listen. So what I can share with you.
I share that point of view, actually, yes.
Is that what he's busy doing, him and his team, is collecting commercially available data that will inform risk assessments, and that's so important for what are the health restrictions during medical certification so that we can better understand them.
Because in recent years, there have been substantial debates about that within members of Congress here. Okay. Dr. Hansman, the 2018 FAA reauthorization included a provision which requires FAA to provide a written response to any recommendation offered by your advisory committee. Has FAA complied with this requirement? And if so, how has FAA and your committee benefited from this provision?
Yeah, so they have replied to them. So we submit our what we call findings and recommendations. Then there is actually an item-by-item response, which I actually believe is on the website on that. That's been useful. We'll sometimes come back and review those topics, and some of the issues are our concerns are persistent. Workforce, the ability to generate workforce, and things like that. So we'll continue to discuss them, but they have been responsive.
But the key goal of the requirement of creating that interaction, that back and forth, has been successful then.
That's correct, and we're an advisory committee, so we just provide advice. They can ignore it or not, right? So.
Absolutely. With that, Mr. Chairman, I'm going to yield back.
Yes, sir, thank you. And now I'll recognize the ranking member from California, Ms. Lofgren.
Thank you very much, and thank you, Chairman Babin, for your question on leaded fuel and the GA environment. I'm interested, Dr. Hansman. It's my understanding that there's engine testing of unleaded fuels by the FAA, but also a certification standards development process that's done by external and voluntary organizations. Does the FAA require both processes? And to what extent, if so, does that keep us from getting to a quicker solution? I think 2030 is too far out. Yeah. And what steps, either Ms. Yak or Dr. Hansman, would we need to take to get to unleaded before 2030?
I think the challenge is that there are no easy technical solutions to the unleaded. So there are ways you can do it, but the things you use to replace the lead are also bad, right? So there's a challenge there. The development of standards using community-based standards is fairly standard worldwide, and this is in part because, frankly, the FAA or any government agency doesn't have the breadth of that. So in both avionics and other components, there is a process by which the communities, the technical communities, get together and say, okay, what's doable, what's not. So I think it's this, you can't accelerate it by cutting those people out of the process if that's the objective. I think the real challenge is hard.
Okay.
You know.
Can I ask a question? In the 2018 FAA reauthorization, as well as at NASA, you were directed to develop a comprehensive research plan for new technologies, including the feasibility of AI applications for certification and developing a certification framework for AI. Now we know that AI is like accelerated more quickly than anyone expected. There are tremendous opportunities, but there are also some risks. Yeah. What's the framework for identifying those risks as we might utilize machine learning and AI generally to improve aviation, Dr. Hansman?
Yeah, so this is what I mentioned a little bit in my comments. It turns out right now we don't have a process for certifying what we call non-deterministic software. So AI changes. Okay. So when you approve, if you approve it today, you don't necessarily know what it's going to be tomorrow.
Correct.
So this is kind of the state of the art of nobody really knows how to do this. So how do you think about providing those guarantees? Do you do it differently? So the current software certification processes don't really match there. The few places where, and it depends what you're using the AI. Are you using it on the airplane, or are you using it to identify challenges? What I have seen is people use AI to get knowledge that then they recode in more frozen software that doesn't work. So there are workarounds,
but you can use it for anything. I mean, you can use it to find cybersecurity holes in your system.
Yeah, so if you're using it on an information basis, it's one thing. If you're using it to fly the airplane, it's a different thing.
Let me ask a question. It's kind of, I know it's always a mistake to rely on the popular press, but on March 3rd, there was a story in Popular Mechanics, I don't know if you saw it, about the Air Force's modular reactor using solid carbon, a carbon conversion reactor to create fuel. Mm-hmm. And I don't know, how seriously do we take this? Is the Air Force, if they succeed in this, how do we integrate that kind of technology into civil aviation, and should we take this seriously?
I don't know that particular case, so I didn't read that issue of Popular Science, or Popular Mechanics. But there are people looking at alternative fuel technologies. You know, the obvious ones are sustainable aviation fuels. People looking at hydrogen. There are some techniques like aluminum reaction that generates hydrogen, things like that. If something looks good, it would move forward, but now you're into the problem that Eric mentioned, which is you now have things that are probably outside our normal certification processes. So this is why the FAA has to be on top of it, right, to be prepared for for somebody to show up.
We'll send you the article. The headline is, "The Air Force's Modular Reactor Will Create Jet Fuel Out of Water and Air." I thought, can this possibly be? So
Yeah.
your take on it will be very welcome.
Okay, yeah, no, I'm happy to do that offline, and I now understand better what they were talking about, so, yeah.
Thank you very much. My time has expired, Mr. Chairman. I yield back.
Yes, ma'am. Thank you so much. And now I recognize the gentleman from Georgia, Mr. McCormick, Dr. McCormick.
Thank you, Dr. Chairman. As a military pilot and as somebody who has a chief who is an airline pilot until a couple months ago, and somebody who's been through Naval Postgraduate School in aviation safety, I'm very impressed, by the way, with your last 10 years of safety. It's fantastic. One of the things that's concerning to me, though, is my wife just showed me an article on 2 junior pilots being paired and some unsafe conditions that recently happened, which, of course, anytime the public's made aware of it, that's probably just the tip of the iceberg. And my concern is with the perceived pressures we discuss in aviation safety of trying to get these flights out and trying to pair these junior cockpits, that we're starting to maybe lose control as we're moving more towards a generationally younger pilot, less experienced. They don't have less military time. They have less landings and takeoffs. They're relying on much more straight and level and automation rather than real world experience of taking off and landing in different scenarios. What are we doing to mitigate that risk?
So I think that this is one of the things I talked about, which is we need to track. It is true that the pilot workforce is changing. People have retired out and whatever. It's been true for a while that the path into the system is different, and your experience is very different. So most, as you know, flying is done on automation, and the pilots basically take off, shut off the autopilot on approach, and then they're there. So there is people are aware of it. It's just the opportunities really aren't there to get the same training. So we have to do that. The U.S., as you know, has a more stringent experience requirement for pilots to come in. So in other parts of the world, pilots will jump into the right seat with 100 hours or 200 hours. So we don't do that, but it is an area of concern. And I think the question is it a problem or not? We don't know. We need to develop the processes to track for anomalies that are indicators.
So I would say you definitely have the resources for that. I've seen your budget. Between the FAA, I've seen.
By the way, it's her budget.
Yeah, but I would say that we do need. We're safe until we're not. Right? We're always one day away from a mishap, and I guess my concern is that we're paying close attention to these junior pairings, especially given the fact that it's actually come to a head now that we've seen that actually happening. I just want to make you aware of that. Do you have anything to add, Ms. Yak?
Yes, I do. I would bring the human factors part into that conversation and pilot training. So we're actively looking at what is the pilot's response to malfunctions? What training materials do we need to provide? How can we change the training, maybe using virtual reality in that? So we're very focused on what we can give to the pilots so that they are more comfortable in those situations.
We'll be paying close attention. With that budget prelude, let me ask you, we went from a budget of $431.8 million to in 2019 for research and development in the FAA to $524.6 million, almost $100 million increase in a few years. What's changed in recent years to increase that budget? What are we spending that on?
Thank you for the question. I don't have the details in front of me, but I would say that the majority has been going towards sustainable aviation fuels, which I think is appropriate. Cybersecurity has a little part of that. New engine technologies or electric, definitely unmanned aircraft systems.
Okay. And what is the budget for the aviation workforce development approximately, if you know?
Yes, I do know that. The Aviation Workforce Development Grant Program has been $10 million a year, and for '23 it was increased to 15.
Okay. And do you feel like it's sufficiently adding to create the pilot workforce that we need into the future?
Yes, I do. I think that's a great start. Thank you
Okay.
for the question.
Similarly, we have another possible expansion of the FAA into the aerospace area. I know the FAA said we want to step up. We want to be part of that. I'm a little bit worried, though. We have a huge, tremendous burden that's growing across the world with aviation already. And then we talk about the NOTAMs problem we had recently, which I know we just recently changed the designator on that, but that doesn't get rid of the problem that went down. It wouldn't be permanently fixed until about 2030 is what I understand. With that said, we're now talking about expanding into space, which is getting very cluttered very quickly. How do you see yourself exponentially or parabolically expanding to that field, given your current limitations?
Thank you for the question. We are working very closely with the industry overall and looking to make sure that we are putting procedures, techniques, and understanding of the technologies and how that new entrant into our system can better be managed.
Okay, with that, I'm out of time. I yield.
Yes, sir. Thank you very much. I'd like to recognize the gentleman from North Carolina, Mr. Jackson.
Thank you. Dr. Hansman, I was wondering if you could give me your sense of the state of the art with respect to electric, hybrid versus hydrogen when it comes to aviation. My general sense, and please correct me if I'm wrong, is that as of a few years ago, there was an assumption that electric hybrid was going to be the future, and then hydrogen sort of reemerged as a possible candidate for that. Could you give me a sense, is there industry consensus or academic consensus that's growing one way or the other?
I think it's an active area that people are trying to figure out. Hybrid electric, let me start, pure electric is very limited in range, so that's really not going to do that much for transportation. Hybrid electric has some potential, particularly when you can get some performance configuration out of it. Hydrogen looks attractive. It's got, it's got what we call high specific energy, so it's a lot of energy per weight, but it's kind of hard to manage. You either have to do it in highly compressed tanks or cryogenic hydrogen, which has all kinds of issues associated with it. So the Europeans have been focused heavily on hydrogen for a few years. U.S. is looking at it fairly carefully. I think hydrogen is probably 30 years out. As a practical matter. And the hydrogen, by the way, is really only a battery, so it's only clean if you get it from a clean source. So there's no direct emissions there. So I think in the near term, it will be sustainable aviation fuels, and hybrid electric has a lot of opportunity.
Mr. Cunningham, now we're coming to you. And in your answer, if you could, because your fourth recommendation basically talks about having a better roadmap for the deployment of this technology, particularly with the use of the demonstrator aircraft. If you could speak to that, if you could just give me, what would a best-case scenario roadmap look like to you for innovation, certification, and deployment?
Thank you for the question. To me, the roadmap would be clear as to what milestones do we need to hit by what point in time to support those next aircraft that are going to be out there. The next gen, whether that's next generation business jet, the next generation single aisle, or whatever it needs to be. If we could work from right to left on what those milestones need to be to ensure that we have, for instance, hybrid electric propulsion matured to a state in a situation where we know how to certify that system to be ready for the next generation single aisle, we could start to have a positive sustainability impact.
Why don't you know the certification thing yet?
So that's something that we need to work in collaboration with groups like the FAA, Transport Canada, and the certifying authorities. Today, the way it works is the propulsion system is largely a thermal engine. What we have to figure out is how do you combine a thermal engine with reliance on an electrical motor with an electrical motor drive and put all that together in a propulsion system to ensure that you're going to have the thrust needed to safely take off and land the airplane.
I understand the technical questions as you present them, but I think you're also presenting regulatory questions. And if I understand you, what you're telling me is that FAA has not told you what the standards are to achieve their certification. Am I right about that?
That's correct. And it's going to have to be an industry and FAA collaboration to come up with that.
Given that we're still in the infancy of this technology, it sounds sort of reasonable that they wouldn't have all the answers yet. Is that how, or do you feel we're far enough along that there should be a little more specificity at this point?
I think we're at the point where we can start having those meaningful discussions and start to define some of those parameters and start to put bounds around the certification requirements.
Dr. Hansen, did you have something on this?
Yeah, I mean, it's actually an interesting thing. So when you go look at the rules, there's rules for engines, which we typically have been, the gas generators And then if you look at a hydro or a hybrid electric airplane, it's almost an auxiliary power unit. So there's a question is, do you certify under the APU rules or do you certify under the engine rules? And so it's really, anytime you introduce something which is fundamentally new, the rules sort of have to be adjusted. And I think part of the issue is now people are still working on what the configurations are going to be. So it's a chicken and egg problem, I think. Yeah.
Everyone has an incentive to figure this out. I mean, NASA, GE, everyone sort of pointed, if hydrogen's 30 years off, that's too far. So this is clearly the next technology that's up. Everyone sort of pointed in the same direction. Am I right?
In my opinion, yes. And the other thing I would like to cite is one of the limitations, and Dr. Hansman said this, that pure electric flight is going to be fairly restrictive for the current time period. A lot of that is based on our battery technology as it exists today. However, batteries will be required to some extent, even in a hybrid electric propulsion type system. So the other thing that I think we can focus on to advance as an industry, as in a country, is the battery systems that will enable any type of electric assisted propulsion.
Okay, thank you very much. You're yielding back. I'd like to recognize the gentleman from California, Mr. Isa.
Thank you. And I know a number of people have asked questions, and so I'll give credit for, you've already been asked questions about drones and drones flying, but I want to continue on that because I don't think we can do enough to ask the basic question. In the decades that we've had, first military and then the desire for a greater and greater number of drones or unmanned aircraft, the FAA has worked very slowly to actually create rules. Entire administrations came and went without aircraft being able to fly in controlled space, even to create rules that they would either comply with or not comply with. If we make the assumption that the goal of our society is to have passenger unmanned aircraft flying from all points to all points in our lifetime, what is your trajectory to get there?
Thank you for the question. You've combined two technical areas, UAS, rightfully so, as well as advanced air mobility. And the work that we're doing for the UAS...
Well, it's been so slow on UAS that,
right.
that, you know, I have to assume when you put people in there, it's going to be even slower.
Yes, but we'll build upon what we've done in the UAS area, so the beyond visual line of sight, the detect and avoid, the making sure that we are able to fly differently, closer to infrastructure, for example. But to answer your question about people, we have a stepped approach to how we're doing that. And first, the first step is piloted. Then we'll start with then we'll go to remote piloted and then autonomy. So we do have a pathway. But
can you give me the timeline? To be honest, I've been reading and watching Jules Verne since I was a child. We all aspire to things that are now technically capable there, but for the FAA giving its approval. So that's why I'm asking for your timeline.
Yes, thank you for that question. I have the research and development side, not a timeline in regards to regulations and that. So,
Okay,
we're
well,
going to crank out the data.
let's forego the regulations for a moment.
Sure.
Because we'll assume that the regulations are bureaucrats' way of stopping things. We'll just set that over there in a corner for a moment. It's okay. We're one of the slowest organizations to make changes probably in the world. From a technical standpoint, are there unknowns that need to be tasked for point-to-point manned, passengered, unpiloted aircraft today? Are there unknowns?
Yes, it depends on the vehicles. So there's crashworthiness standards. There's quite a bit that there's still left to do.
Well, let me go through. You're back to the bureaucrats and standards. So let's go through it. Does the technology exist today, and have all the questions been addressed for remote or autonomous unmanned flying? In other words, have we flown aircraft from place to place that are large enough to carry somebody, and thus including collision avoidance capability equal to that of a pilot in the cockpit? Yes, sir.
Let me jump in a little bit on this. So there are many questions like that, and I think it's not a bureaucracy thing. It's actually a safety thing. So how safe does it have to be, and how do you guarantee that the software can do it? So do we fly UAVs today? Absolutely. Do we have collision avoidance capability? Absolutely. Do we have the capability for the system to figure out what to do when there's someone in the back of the airplane who is having a cerebral hemorrhage and what the things? So the issue is, have we anticipated everything? And that's really the state of the art.
And that's why I'm asking for a timeline for a reason. These are all very legitimate points. I'm a pilot with a current cockpit capability. I'm 70 years old.
Yeah.
I'm acutely aware that the technology on my aircraft is better than the pilot behind the stick.
Yeah.
So having said that, the only question I'm asking is, if we know or can know, and if we can address all of the questions that need to be answered, then I agree with you. There's a lot to be answered, but instead of saying, well, these questions are there, and then we have to resolve them through the bureaucracy of safety, the question is, can the next Burt Rutan know that the questions are all out there? When he or she can deliver the aircraft that meets that requirement, they can get a ticket to fly.
So let me give you one example, which is you're probably aware of this, but there is a system now that's been approved, which is the Garmin system for a board where if a pilot becomes incapacitated, it will automatically land the airplane.
You got to push the button, but yes.
Yeah, you have to push the button.
And it's going to be available on the Cirrus very shortly, so I'll be safer.
Right. And so, but the criteria is, and the reason why that was approved is, it was already accepted that if the pilot was incapacitated, you're going to have an accident. So it didn't have to be as good as a normal airplane. It just had to be good enough to get on the ground. That's a different standard than when you're going to take, my wife to hop in the airplane to go on a trip. So this is the fundamental, I think, research question and approval question and challenge for the FAA is, how do you do the underlying work to know whether technology is good enough to turn in the system, because you don't want to compromise the safety of the system.
Thank you, Mr. Chairman. Thank you for the indulgence of time.
Yes, sir. Thank you very much. Next, I'd like to recognize the gentleman from Alabama, Mr. Strong. Oh, I'm sorry. I apologize. The gentlewoman from Colorado, Ms. Caraballo.
Thank you, Mr. Chairman, and thank you to Ranking Member Sorensen as well for the hearing today. Very excited to be here for our first subcommittee meeting. Earlier this week, I met with a group of firefighters from Colorado, and one of the issues that they brought up was PFAS. And I know that in particular, one of the airports in my area, in Greeley, is curious about what kind of the future of firefighting substances is going to be, as I know that airports have historically used firefighting foams containing PFAS, and it's still something that the FAA requires airports to have for my emergencies. But my understanding is that the FAA is conducting research to identify suitable alternatives. So Ms. Yak, if you could provide any updates on that research, has the FAA identified any alternatives that meet your standards?
Thank you for the question. We've been very active doing the testing at the Technical Center, built a facility. We've tested over 750 research test products, as well as 49 formulations. What has been key is that this data has been provided to the Navy, and they're the ones that released a fluorine-free foaming specification, and are obligated to ensure that foam is available by October 1st, 2023, and we're going to be using that QVL list for our selections too.
Thank you. Dr. Hansman, anything to add?
No, I concur that this has actually been an active area that the FAA has been working for a number of years because of this urgency of this problem.
wonderful to hear that there is continued research. I know that the firefighters that I met with are going to appreciate that. And in a related issue around health, it's a particular interest of mine as a physician. From your perspective, in terms of crew health, has the FAA given adequate attention to passenger and crew health in its research activities, for example, with fume events like bleed air or seat pitch and size studies?
Thank you for the question. Yes, we have two initiatives underway. We did do some research on seat pitch size from an evacuation point of view to make sure that it's safe to evacuate, and that did come out positive. And then for cabin air quality, which is what you're asking about, we have issued a study by Kansas State to capture information on these bleed air contaminants and ways that we can monitor them. Thank you.
Dr. Hansman, anything there?
No, I think Shelley.
Great, thank you. I will, I think, direct my next line of inquiry to you, Dr. Hansman. There are many universities in Colorado that are just involved in research overall, and the University of Colorado Boulder in the past has been a recipient of a Centers of Excellence grant award. Do you have any suggestions on how the relationship between the FAA and universities can be strengthened? Has the Research, Engineering, and Development Advisory Committee looked at the role of universities in academic research contributions to FAA's R&D portfolio?
Yeah, I mean, there clearly is collaborations, and it's typically done through the Centers of Excellence. There are a whole series of Centers of Excellence in different sort of topic areas. I would say one of the things that happens is they get set up, but the funding for activity is not guaranteed as part of that. So their health or activity can be subject to internal priorities within the FAA. So you may have a center that's there on paper but not doing too much, and then you have other ones that are very active. So there is a variability.
Wonderful. I appreciate everyone's time, and Mr. Chairman, I yield back.
Thank you. I'd like to recognize the gentleman from Florida, Mr. Posey.
Thank you, Mr. Chairman. Mr. Cunningham, as you noted at the start of your testimony, I represent the Collins Commercial Avionics business in Melbourne, where Collins makes radio altimeters for thousands of aircraft flying daily around the United States and the world, among other commercial avionics systems critical for safety of flight. Although I know this is a separate business line than the electronic systems you lead, both avionics and power and control systems are critical parts of any aircraft, pilot, or passenger safety. Concerning the rollout of the C-band 5G, what lessons can we learn from this experience about how we can better use federal R&D programs to do early research, testing, and development for win-win solutions to government and industry in the case of future spectrum interference or other technologies that could have safety impacts? You know, does the FAA have a dedicated R&D program looking at this for future spectrum rollouts like 5G, 6G, or other areas where we might have potential impacts?
Thank you for your question. I don't know if there's a current program out there that's supporting it. I apologize, I don't have that knowledge. But what I would say is there could be a great benefit from collaboration on doing a comprehensive risk assessment of where we could run into these issues in the future. What could be the areas of vulnerability, and how can we collaborate on technical solutions that would help us avoid running into those or realizing those risks when we get to that point? Unfortunately, the consequence is we end up spending our time and resources reactively on fixing those problems instead of proactively on advancing the industry in the directions that we want to go. So my general recommendation would be that collaboration on risk assessment so we can focus the funding, the resources, and the time and energy of both government and industry.
Yeah, have you seen any problematic delay in the market that you may have observed by people being able to have altimeters that are 5G compatible?
I apologize, I don't have knowledge to answer your question, but we can, I can take that for the record and we'll come back with that answer.
Great. Ms. Jack, do you know if all the aircraft now have 5G compatible altimeters?
Thank you for the question, but unfortunately, I do not have that answer with me. We can also take it
Yeah,
as
I
an
noticed
IOU.
that there had been some requests for a little bit longer time for people to be able to make that switch. Do you know, Doctor?
It's my understanding that there are still airplanes that are not restricted because of that, but so there's an operational restriction because of the concern.
Okay. Ms. Jack, I represent the Kennedy Space Center in Florida Space Coast. Space launch is obviously important to my district, but so often travel and tourism is as well. Airline delays caused by typical Florida weather and pilot shortages can be exacerbated by increased space launches. I'm familiar with the Space Data Integrator project to better align space launch data with air traffic controller data, but what is the FAA doing to research debris modeling, individual vehicle risk assessments, hazard area reductions, and traffic flow management to influence and reduce the temporary flight restrictions to limit the impact of space launch on air travel?
Thank you for the question. I'm very familiar with the Space Data Integrator also. It is a new capability that we are using to integrate commercial space into the airspace, and it does include some debris modeling and sharing of aircraft hazards. The prototype of that system was developed and tested at the Technical Center. Now, to answer the second part of your question, we are working very closely with the commercial space industry members, and we are working actively on some new procedures and technologies to reduce the amount of airspace for these operations, quickly respond to contingencies, as well as releasing that airspace.
Okay, very good. Thank you, Mr. Chairman. I yield back.
Yes, sir. Thank you. I'd like to recognize the gentlelady from Michigan, Ms. Stevens.
Thank you, Mr. Chair. Turbulence is the top cause of injuries to passengers and crew, and it costs airlines as much as $500 million per year. However, due to its sudden and severe nature, clear air turbulence poses a unique threat to the safety of those on board. Unfortunately, recent studies show that turbulence will worsen in future years as a result of climate change. For example, one analysis found that the prevalence of transatlantic wintertime clear air turbulence will increase significantly in all aviation relevant strength categories as the climate changes, with the most severe turbulence seeing the greatest projected increase of 149%. These findings are obviously concerning and warrant FAA's immediate prioritization. Therefore, Ms. Yek, could you answer these questions for me? How is the FAA currently tracking turbulence incidents?
Thank you for the question. That's not anything in my background. It's not
Okay.
research and development.
Okay, so you don't have any information on clear air turbulence and some of the technologies that we need to identify it, and if so, has the FAA attributed any increase to related climate change?
So, thank you for the question, and it looks like John wants to say something too.
Okay, John can
But,
talk too.
Yes, we are actively doing research around turbulence. I thought your question was about tracking the numbers. But yes, our focus is collecting where it is located, communicating that digitally to the pilot, and providing that information so that the pilot's aware of what turbulence is ahead.
Yeah, so there's a lot that's been done on attempting to forecast clear air turbulence. So some of the types of clear air turbulence, like on the North Atlantic, has to do with the edge of the jet stream or downstream of mountain waves and things like that. So some of it is forecast. The real concern is unforecast clear air turbulence. There has been technology development on some LiDARs and look-ahead sensors. None of them at this point have been
Well, and there's an
technically-
integration, right, with as our climate changes.
Yep.
How are we projecting those impacts to, flight patterns, particularly transatlantic? So are we aware of, are we weaving in climate considerations and warming patterns into the research? It's great that new technologies are coming on board as well.
Yeah, they come into the forecasts the forecasts are validated in whatever. So the real issue then is when you have an area of turbulence, you need to avoid it. So can we be efficient and not burn extra fuel
Right.
and make the problem worse, right?
Or catch it beforehand, because we have some instances where a cloud will rise. Now, are we aware of any cross-agency collaboration? And again, Ms. Yak, understanding your portfolio only goes so far, but are you aware of any cross-agency collaboration?
Oh, absolutely. When we do our research and development, we're very much working with the National Weather Service. So definitely a lot of collaboration there.
Yeah, great. Well, we'll continue to encourage you to work with NOAA and certainly encourage the FAA to communicate clearly to consumers so that we have not only the consumer safety, but the flight attendant safety, because we know that the dangers in that profession are only rising. And allow me to just say for the record, many of us are blessed to know educators. I am very blessed to know a principal from New York who happens to serve as a full committee member on this sub. And so I appreciate his time and patience with me, and I yield back the remainder of my time.
Ma'am, thank you. I'd like to recognize the gentleman from Georgia, Mr. Collins.
Thank you, Mr. Chairman. Mr. Cunningham, I am a small businessman and an entrepreneur by trade, and so when I look at things, especially in the federal government, I like to focus on just what I see as far as regulations and how they affect small businesses and their ability to not just compete, but to innovate. And it's my view that we should get rid of some unnecessary regulations and that are slowing down innovation and not improving safety. And as your company does research and looks for new ways for our airspace to be safer and more efficient, have you noted any regulations at the FAA that are preventing the implementation of new discoveries?
I don't have any that, thank you for your question. I don't have any that I would be able to comment on today that I personally have noted. I can certainly take that for the record and come back with any feedback that the company has. What I would say is, as we move forward, something that Dr. Hansman and I have commented on is a lot of these new technologies provide a lot of opportunity for the future in many ways. But if we aren't able to streamline the way in which we come up with the new regulations, policies, guidelines on things like how to certify a hybrid electric propulsion system or things like that, we could delay the introduction of technology which could vastly benefit not just sustainability, but U.S. competitiveness, as well as other factors in the industry. So I think I appreciate your question, and I will take that back to see on my add-on comment is I think there's as much focus proactively at looking forward on how do we be more efficient on how we work together for the next round of policies and regulations.
Yeah, and if I remember right, a few questions back, you said you found yourself being more reactive to regulations and things instead of being more proactive. So, and I don't know if Mr. Henson, if you want to.
Yeah, I would note that the FAA has been trying to be a little bit more upfront on it. So the way the process works today is, the FAA doesn't really get into it until someone shows up with something, says, I want to certify this airplane engine, whatever. They do have, and I can't remember the name of it off the top of my head, but there is a organization within the FAA which is working with industry prior to application for their airworthiness certificate. So to try to figure out these things ahead of time, so when they do show up, it's not news to the FAA. So there is work going on there. People are trying.
Yeah. Well, Ms. Jack, I'll ask you kind of the same question then. From the FAA's perspective, what do you think the agency can do to encourage and support R&D by the private sector? And what regulations do you think may be inhibiting that goal?
Thank you for the question. More active interaction with industry, academia, and government. We have a strong base there, and we're using it more and more. We also have tools available, cooperative research and development agreements with small business or any business size to be able to come speak with our subject matter experts, use our laboratories, try it out, allow us to understand where it's going, get the data so that we can then provide that information to the certifiers so that they're better prepared to certify that new entrant or that new technology.
Great. Thank you. Mr. Chairman, that's all I got to yield back.
Thank you very much. I'd like to recognize the gentleman from New York, Mr. Bowman.
Thank you so much, Mr. Chairman. Ms. Yak, thank you so much for your testimony. Last year, I and my good friend, Mr. Randy Weber, introduced the Airborne Wind Research and Development Act. Our bill follows up on recommendations in a recent report from the Department of Energy that considered R&D pathways for this potentially game-changing clean energy technology. As noted in the report, the FAA will also need to be involved in this effort. Airborne wind systems may operate at elevations between 200 and 1,000 meters, where there is currently a knowledge gap in our domestic wind resource. Following up on one of the report recommendations, would the FAA be willing and able to assist DOE in better characterizing this resource?
Thank you for the question, and yes, that would be something that we'd be able to get our subject matter experts working with DOE on.
Awesome, great, thank you. The report also notes that there are U.S.-specific regulatory questions which will require engagement from the FAA. Are you aware of these issues? In either way, can you commit to working with DOE and emerging industry stakeholders to address them?
Thank you for the question. I cannot commit on answering that, but I can take that back and make sure that we have FAA actively involved.
Awesome, thank you. Another question on workforce equity. Each of the testimonies today highlighted emerging technologies such as AI that will increasingly be part of the FAA research agenda moving forward. As REDAC has made clear, FAA's technical workforce will need more skills to confidently utilize and develop these technologies, and I think we would all agree that underrepresented groups in STEM fields, especially people of color, are an untapped pool of talent that can fill this gap. To that end, the FAA created the HBCU program to address the President's executive order on advancing equity through HBCUs. Dr. Hansman, what kind of role has REDAC played in defining a strategy for this program, and how do you plan to engage going forward? Are there any concrete measurable goals you can share around equity? And an additional question, can you speak a little bit to the K-12 space, if possible, around STEM education and closing some of this knowledge gap?
So I probably can't talk about it from a REDAC focus because REDAC has really been focusing on the technical issues specifically. I know personally and from my own MIT activity and whatever, this is a very high area of priority, and within the overall community, I would say the aviation community in general is doing that. So I'm actively involved in a STEM activity at a little airport, we fly at. So I think there's interest, there's desire. I can't speak to the specific on the HBSU.
Yes. Do you have something to add, sir?
Yeah, Congressman, if I can add. So this is an area that Collins Aerospace takes very seriously. At least 50% of our community engagement resources go towards STEM education in the communities in which we exist. So as an example, in Rockford, Illinois, Collins Aerospace provides actually the funding to a local children's museum. We've created a mobile STEM lab because a lot of the underprivileged areas don't have transportation to get to the children's museum. So we've actually created a Collins Aerospace mobile STEM lab with the Discovery Center to be able to take those resources to the kids to be able to give them those experiences. And really focusing on late elementary school, case or 6 through 8, and getting them ready and getting that interest early. Then beyond that, what I'd say is, as we look at the recruiting efforts and really building the talent pipeline in industry, how you recruit goes a long way. As a lifetime member of the National Society of Black Engineers, I can say that the recruiting that we've done with Region 5, Region 6 of that group has been tremendous, and we've pulled a lot of good talent into the Rockford area. And I know that the rest of the company has also benefited from recruiting in other regions with that group as well. And it's just one example, but how you recruit has a big effect on where you can find the best talent.
That's excellent. Thank you so much. One last question, if I can. And this question is from Ms. Yak, but anyone can comment. Ms. Yak, can you please expand on how the FAA is thinking about artificial intelligence as a proactive tool to prevent cybersecurity risk? In addition, how are you mitigating the risks associated with utilizing these automated tools?
Thank you for the question. We're very active in AI and ML, artificial intelligence, machine learning, and our first step there is educating our workforce on these technologies. We have a micro-credentialing program in place, and we are now testing use cases of how we can best use that technology in collecting data and being able to use it. One example is aircraft structural health monitoring, for example. And I'd also like to take the moment that we have a very strong STEM program at FAA, and we personally have an internship program with minority serving institutions and HBCUs, so it's a very high focus area for FAA too.
Thank you so much. I yield back.
Yes, sir. Thank you very much. And now I would like to recognize the gentleman from Montana, Mr. Zinke, Secretary Zinke.
Well, thank you, Mr. Chair, and thank you for your indulgence. We were all run between committees. So UAVs. I've been dealing with UAVs probably as long as anybody, probably as long as you and I. Yet the world is moving ahead. We're no further about integrating the UAVs than we were when I first started in 2008. Some of the technologies moved forward. So we didn't have to think about, artificial intelligence. We didn't have the technology in chips. But we're no even further on a pilot program because the rest of the world looks at UAVs as a tool for wildlife management, for wildfire management, for looking at fuels, transportation systems, for integration of energy in the environment. So there are tools, but we're restricted. We're restricted, still line of sight, and we started with saying, well, we'll increase the training. So we'll do that and more certifications, and we went back and forth. And then we made an arbitrary rule about 52 or 82. And what's the difference between weight, between 50, 40, 50, 80? So we made these arbitrary classes based on weight. So where are we? And is there a plan to integrate at least a pilot system so we can test and develop and the industry side it can catch up? Because we're behind.
Yeah, I mean, it has been a challenge for a while. In fact, a lot of companies were testing in Australia and New Zealand because the rules were better there. It's easier to fly airplanes.
And the EU.
Yeah, yeah.
And Canada. And everyone else allows the flight without line of sight that I know of.
Yeah, I think it's, I'm not going to defend all of the protocols and whatever. All I'm saying is it is a challenge. This is sort of goes to the points I was making before is what's the process to approve things and not put restrictions in. I would say that, on the weight thing, that was specifically based on risks to people on the ground, given assumptions of, if there was a mishap, what would be the risk to people on the ground. So that was the basis for where the weight came in.
I think it also had to do with the Scan Eagle and it too at the time, but
yeah, we actually wrote a paper. Well, we wrote a paper. I'll send you the paper on it. Okay, but
don't get me wrong. I'm not adversarial. I just want to fix this.
Yeah.
So how do we fix it, and what do you need us to do?
Yeah.
In order to give you the tools necessary to get it done in a reasonable timeline. We've been doing this for 15 years. So can we get it done in the next 2 years if we give you the right authorities and do a test program and prototype? Can we get it done in the next couple years if we give you the help and you identify what the help is needed?
So let me just point out to two different categories. So the one is the real UAVs or small UAVs that we've had that are sort of expanding, which have been a weight limit in whatever. That's one sort of path that's gone along. There are some very interesting things happening right now with major players, companies like Whisk, companies like there's a couple other that are automating caravans and things like that are out in test programs. So you're about to hit a situation where there are applicants that are going to come to the FAA with a caravan that they want to fly fully autonomously under certain things. So it's going to be pushed by industry. And I think this is what we were talking about before is the FAA needs to be in a position that they can intelligently determine what the appropriate limitations are for that. And right now, that's the research I think that needs to be done is how do you figure out, how do you set the boundaries, how do you incrementally increase the amount of activity?
It would be helpful to have a pilot program so at least we go forward.
Yeah.
Because there's precision farming. The applications are great, but the applications are being limited because you can't do it with under the line of sight.
Yeah.
And we looked at restricting airspace, different areas, oversensitive sites. We've looked at altitude adjustments, give them 400 feet above. But thus far, nothing has occurred. There's nothing on the horizon that I can see.
Yeah.
And industry is banging on my door saying, we want to be at the front edge of this because UAVs are coming. They're here. And we got to be up front. And it seems like the FAA, at least on this issue, is a lead weight.
If I may, I would like to just say you have given us a good start of an infrastructure with our centers of excellence doing a lot of great research for us. We also have the test sites that are available that are able to pilot technologies and use cases in that. I'll take back your concerns. I think we have the start of a good infrastructure and support from Congress, and we'll continue to do more as we roll it out.
But I'd say one thing to be careful of is a demonstration is not enough. It's easy to do a demonstration, have it work on a good day when it's sunny or whatever. So the real challenge is that if you're going to prove something, it's going to work all the time, and it can't create a hazard. So we have this is the challenge of an incredibly safe system is, you know, this now means that they don't want to screw it up. So how do you make sure you know, it's safe if you don't improve the technology, right? Because you haven't degraded safety, but you've held it back. So that balance is a really tough thing to do.
I'd also remind you what the Wright brothers said, just fly.
Yeah.
Thank you, Mr. Chairman.
Yes, sir. Thank you. Appreciate that very much.
Yeah.
Well, I want to thank the witnesses for your valuable testimony and all the members for your questions. The record will remain open for 10 days for additional comments and written questions from members. And so thank you all again. Really appreciate it. Good information. And with that, the hearing is adjourned.